Chapter 10.0 Carboxylic acids and its derivatives. In Chapter 10.0 Carboxylic acids and its derivative, there are 5 subtopics. 10.1 You have to know how to write the general formula of the carboxylic acids. 10.2 Naming the compounds according to the IUPAC nomenclature. 10.3 Physical properties of the carboxylic acids. 10.4 Preparations of the carboxylic acid. And the last one, 10.5 Chemical properties. So what is the functional group for the carboxylic acids? This is a functional group for the carboxylic acids. Name of the functional group is carboxyl. Then you can see from the structure, there are carbon. It forms double bond with the oxygen and it forms single bond with the hydroxyl group. So if we write in the condensed structure, it becomes COOH. So this is a functional group of the carboxylic acid. Okay, next, general formula of carboxylic acids. For the aliphatic carboxylic acids, R that bonded to the carboxyl group, it can be alkyl or hydrogen. The alkyl group, it can be one carbon or more than one carbon. For the aromatic carboxylic acids, AR we refer to the aryl or benzene that bonded to the carboxyl group. So this formula also can be written as a condensed structure RCOOH or RCO2H. Nomenclature of carboxylic acids. These are carboxylic acids starting from the carbon 1 until carbon 10 and together with its IUPAC name, the structural formula and its IUPAC name. Okay, next, let's see the nomenclature of the carboxylic acid based on the IUPAC nomenclature. So, first, let's see the aliphatic carboxylic acid. According to the IUPAC nomenclature for the carboxylic acid, first, you need to find the parent chain, which is it is the longest carbon atoms that contain the carboxyl group. Next, you have to number the chain starting from the carboxyl carbon atom as the carbon 1. For the example, okay, we have this compound. So, the longest carbon chain, it is continuous bonded to the next carbon. Then you find the longest carbon chain. The longest carbon chain is 1, 2, 3, 4, and 5. So the longest carbon chain including the carbon of the carboxyl group is 5 carbon. Next, carbon number 1, we refer to the carbon of the carboxyl. Okay? Next, the carboxyl group is at the terminal, therefore carbon of the carboxyl group is not numbered. If there are one carboxyl group, So carboxyl group is always at the end of the carbon chain. And if there are two carboxyl groups, the carboxyl groups will be located at the both ends of the compounds. In naming the carboxylic acid, which is you have to replace the E in the alkanes by the oic acid. For the example, alkane, if alkane is methane, so you substitute the E, the last letter, with the oic acid, so it will become methanoic acid. Okay, let's see for the example. Still using the same compound. So, since the carbon of the carboxyl is the carbon 1, so for the naming, okay, the first carbon is a 1, 2, 3, 4, 5. So at the third carbon, there are substituent. Okay, this substituent only one carbon, so it is methyl. And when naming this compound, according to the IUPAC nomenclature, the name is 3-methyl-pentanoic acid, not 3-methyl-1-pentanoic acid. You don't have to put number for the carbon of the functional group in IUPAC nomenclature because the carboxyl group always at the end of the carbon chain, so it always number 1. So the correct IUPAC nomenclature is 3-methyl-pentanoic acid. If two carboxyl groups present, add dioic acid to the name of parent alkane, and it becomes alkane dioic acid. For the example, this compound, there are two carboxyl groups at both ends. In the way to number the parent chain, you can number from the left to the right, another way from the right to the left. In this compound, you can see that they are methyl, and the methyl, okay, if you number from the left to the right, the positions of the methyl at the carbon 3. If you number the compound, okay, the carbon chain from the right to the left, methyl is located at the carbon number 4. So you have to make sure that the substituent must be at the lowest number. And the first one is correct because methyl is located at the number 3 compared to the number 4. And the name is 3-methylhexane dioic acid. The carboxyl group is given priority over other functional groups. Other functional group is treated as substituent if present. For the example, this compound, there are two functional groups, carboxylic acid and hydroxyl. So carboxylic acid is given priority compared to the hydroxyl for the parent. And hydroxyl, it will become substituent. So for this compound, the longest carbon chain is 6. And at the 5th carbon, there are hydroxyl group bonded to the carbon number 5. And the name for this compound is 5-hydroxyhexanoic acid. Carboxylic acid with the double bond are named as alkanoic acid, as we refer to the positions of the double bond. For the example, in this compound, you can see that they are double bond. It is a functional group for the alkene. So, starting from the carbon of the carboxyl, then you find the longest carbon chain. It is 6. And at the 5th carbon, they are methyl. So the name is 5-methyl-3-hexenoic acid. So the 3 is the positions of the double bond in the compound. Another example. Okay, this compound got 2 carboxyl group at the both end. So you can number it from the left to the right, or from the right to the left, because the carbon-carbon double bond is located at the middle. So let's say I numbered it from the left to the right. So the name is, okay, you can see that the structure in the form of the cis. So it becomes cis-2-butene-dioic acid. 2 we refer to the positions of the carbon-carbon double bond in the compounds. A cyclic carboxylic acid is named as cycloalkane carboxylic acid or cycloalkene carboxylic acid. And the carbon atom which is attached to the carboxyl group is numbered as carbon 1. Means that the carbon atom in the cyclic, okay, that got the COOH is numbered as the carbon 1. For the example, okay, so this carbon numbered as the carbon number 1 because it has COOH. So carbon number 2 goes to the carbon of the double bond. Okay. Number 3, number 4, number 5, 6. So the name for this compound, IUPAC nomenclature for this compound is 3-methyl because at the 3rd carbon, they are methyl group. And 2-cyclohexene, 2 we refer to the positions of the carbon-carbon double bond. And you ended with the carboxylic acid because it is a cyclic carboxylic acid. Another example, okay, this is a cyclopentane carboxylic acid. You don't have to put 1 cyclopentane carboxylic acid because there are only 1 carboxyl that bonded to the cyclic. So it always number 1 and you don't have to put 1 in front of the nomenclature. A cyclic dicarboxylic acid is named as 1-cycloalkane dicarboxylic acid, 1-cycloalkene dicarboxylic acid. For the example, okay, so there are 2 carboxyl group in the compound. The first carbon, let's say this one is the first carbon, and then second carbon, we refer to the carbon that also got COOH. Then the name of this compound is 1,2-cyclohexane dicarboxylic acid. Another example for the compound that has 2 carboxyl group and 1 double bond, and it also has other substituent, chlorine, and chlorine it becomes chloro. So the number, the first carbon, this one, okay, the second carbon, this one, and next until carbon number 6. So the name of this compound, 4-chloro, positions of the chlorine at the carbon number 4, 1, 2, we refer to the positions of the carboxyl group at the carbon 1 and 2. Okay, cyclohexene dicarboxylic acid. Okay, next, aromatic carboxylic acid. Aromatic carboxylic acid, we refer to the aryl group bonded to the COOH. And the parent name becomes benzoic acid. For the example, okay, you can see that benzene ring bonded to the COOH. So this one is the benzoic acid. And the first carbon, we refer to the carbon benzene that bonded with the COOH. That one is the first carbon. So the next carbon, number 2, 3, and the chlorine is located at the carbon number 4. So the IUPAC nomenclature for this compound is 4-chlorobenzoic acid. Or you also can name it as para-chlorobenzoic acid. When we pronounce it, it is para. When you write the IUPAC nomenclature, you just write P. Okay, so para means that the positions between the carboxyl and substituent 1, 4. 1 we refer to the carboxyl and 4 we refer to the other substituent. So this is a para, for the example, para-chlorobenzoic acid. An aromatic dicarboxylic acid is named as 1 as benzene dicarboxylic acid. For the example, okay, there are 2 carboxyl group bonded to the benzene ring. So the name, okay, when you number the carbon, okay, make sure that both of the carboxyl group must be at the lowest number. So the name is 1,3-benzene dicarboxylic acid. Another example, okay, same. You have to make sure that all the substituents must be at the lowest number, including the carboxyl group. So the name is 2-isopropyl 1,4-benzene dicarboxylic acid. At the second carbon, there are substituent of the isopropyl, and the carboxyl is located at the carbon number 1 and 4. Common names with the parent chain less than 5 carbon. So let's say for the methanoic acid, common name is the formic acid. Ethanoic acid is the acetic acid. Propanoic acid, the common name is the propionic acid. Butanoic acid, butyric acid. And the pentanoic acid with the 5 carbon, the common name is valeric acid. So you should know these 5 common names of the carboxylic acid. That's all. Thank you.